Hello everyone, my name is Sandeep. I work at this company called Hasira. We make tools for GraphQL developers, so people like yourselves who might be interested in using GraphQL on any stack that you use, right? And today I'm going to talk a little bit about using GraphQL with a .NET stack. However, you can take the approach, you can take the concepts and apply it to any language framework of your choice. As you will see, we kind of circumvent this API middleware and go straight to the domain in the database. But I'll save that for the subsequent slides. So here's what we are going to do. I'm going to take just one more minute to introduce myself. We will take a look at GraphQL for those of you who are new to GraphQL, who have heard of GraphQL but have never quite sunk your teeth into it. We'll take a brief look at GraphQL. Hopefully, it'll just be 5 minutes. And we will also take a look at some concerns that API platform architects or developers need to kind of grapple with as you kind of build out your API platform or data access layer inside an organization. These are concerns that everyone has to face, especially as your team, as your data landscape gets more complex and it evolves and grows. These are concerns that everyone inevitably faces as their organization scales. So we'll take a look at some of them, and then we'll quickly move to something slightly more productive, which is a demo of how these things will work. And towards the end, hopefully, we'll have some time left over for a Q&A. So that's the plan. I am not sure if you got my introduction in the beginning, but I'm the field CTO at this company, Hasira. We build tools for GraphQL. I started my career building .NET tools, building applications with .NET 2.5-ish is where I started. Watched the transition to 3 and then went on to do other things. So C# and .NET hold a special place in my hand. And I used to use that old clunky Visual Studio code editor plus CI/CD tool plus everything in one, right? So that's how I began my journey. And very excited to be here and talking to you about .NET and GraphQL. So without further ado, let's talk about GraphQL. Quick, and I'll keep these sections quick and rolling. If you have any questions towards the end, I'll be more than happy to take them. So quick bit of trivia. GraphQL originated in Facebook, an organization that is very much like an enterprise, lots of data, lots of teams, and more importantly, a lot of scale. I think nobody in the world had seen very few teams in the world had seen scale the way Facebook and I think the WhatsApp team saw. I believe around between 2010 to 2015. And this was also the time they introduced React into the developer ecosystem. React components started to become a thing. People started to understand the kind of reinvented for most of you folks who've been around. This should sound familiar, but the idea of data hierarchies and architecture and individual components being able to represent their own needs asynchronously, all of these things started to take off in a new way. Of course, in a new fashion between in that time frame, 10 to 12 to 15, I think, is the right window for this. So GraphQL emerged from developers being lazy and refusing to write new APIs. And they said that, hey, we will come up with a query language. We will write one endpoint. Let's say it's some domain / GraphQL. We will define a way in which people can express the query, that we'll define the semantics of this query language so that front-end application can request whatever data they want. And without getting into the implementation details of how we will service that request, we will be able to return any such request with the data that has been requested. So you can see this GIF on the right, where depending on the request, you have a response that goes from your GraphQL API. The idea is that you bring your own data and write your code, but essentially you build out a GraphQL schema that has types in it. You write resolvers, you generate resolvers, you do whatever, that's completely up to you. But define a schema, expose the schema to your front-end developers, ask them to query whatever they want against the schema. You have types that will help you pull this information out from the underlying implementation and return this response data set to the consumer applications. Whatever else you focus on in this half an hour's worth of talk, if there's one thing you want to take away, it is the fact that GraphQL brings types that are consistent across the underlying implementation. You could be using GraphQL on top of a single table, a single database, 20,000 databases, but you will ultimately represent them using one type system, which you define. But the ability to do that is what differentiates it from, let's say, a JSON REST API with Open API specification, where you have information about individual endpoints that are discrete, but GraphQL is kind of, I mean, if you kind of squint your eyes a little bit, ignore OData and some of these other frameworks from the past, the first time that you have such a schema-driven approach that does this. In the modern world, again, for people who've been around the block, you know that SOAP and other protocols have kind of done the same thing, but this is the new wave of the same frameworks, so to say. Using types helps GraphQL kind of self-document itself. That makes for an interesting experience. We will see that in the demo. And most implementations of GraphQL are in HTTP and JSON. If people want live queries and things called subscriptions in GraphQL, which let you access data in a real-time fashion, then you can use WebSockets as well. And there are libraries that can help with this entire implementation. So that's a not so quick trivia around GraphQL. The important thing is that it's a single endpoint. You specify what you need, you get exactly that data. This lets you declaratively define the needs of a single component in your application. And that's it. No one needs to write any code. No expensive interactions between front-end and back-end developers to figure out the API spec and to test it, to have test data, and all of these things. You get away with all of that. Once you build a GraphQL schema, any permutation of requests in that schema is kind of supported because you kind of do the hard work with the way you write resolvers, which should sound ominous, and we are going to get into this. So GraphQL evolved, as I said, from front-end engineers not wishing to get into extended back and forths with back-end engineers, right? So it emerged as a layer on top of REST APIs or whatever your domain APIs were, written and requested by front-end engineers. So over time, what has happened is that the scope of building GraphQL has gone back to back-end engineers. This is because when you had a well-defined domain API set, it was easy to build GraphQL. It was okay to build GraphQL, a layer of GraphQL on top of it. But the moment you need to introduce new data into the mix, you need to troubleshoot performance, because if you notice in the left hand side of this diagram, let me see if I can get my pointer turned on. You have APIs that talk to other APIs that talk to your database. Now anyone who's ever written code that spans more than 5,000 lines of code and works with multiple databases will know that this is a very hard problem to solve. You don't know what is going on. Multiple pieces of code talking to each other had unnecessary latency, and it's very hard to troubleshoot, and it's very hard to standardize performance in a single place. So a lot of these patterns kind of started moving back to the backend engineering scope, so to say, for full stack developers. The balance kind of tilts more towards backend engineering systems where you get closer to the underlying domain. Right. So this is one of the things that has happened in this 9 years of GraphQL, by the way. The tooling ecosystem that lets you build a subgraph, and we'll get to the definition of subgraph as well, but it should be fairly self-explanatory. You build a subgraph, one team owns a subgraph on one or more data sources. You write some code, which is called resolvers. This entire thing is called a subgraph, right? So tooling started in the GraphQL ecosystem being very schema first, where people would laboriously handwrite a GraphQL schema. Step two is kind of write resolvers to help implement the schema. And a few years of doing this, after the initial hype kind of wound down, people realized that, hey, maybe there is a way in which we can generate the schema instead of having to handwrite the whole thing. We have a complex domain. I don't want to sit and write thousands of lines of GraphQL GraphQL schema. In some cases, I already have APIs and database domains which have defined what the schema should be. Why am I building another layer on top of it? That's the kind of thinking that led to people to do other things like code first, where if you have code, you can generate a GraphQL schema on top of it. So this is code first. And the third approach is domain first, where if you already have types in your domain, which usually come from your database, just generate the GraphQL schema, most of your GraphQL schema from it, and allow the definition of business logic to kind of customize this if any of that is needed. Over time, people have realized that this is academically very sound schema first, but it takes a lot of time and it doesn't solve all the problems. And the adoption has kind of started to shift towards code first and domain first in the first 2-3 years, and now there's a lot of stuff happening here. We'll kind of take a look at what is happening in the ecosystem in the recent past as well, right? But a quick caveat here: these are all steps that you will take to seed your GraphQL schema. Now, and like if you build applications, think about all the different tables, all the different models that you have in your domains, in your domain, and think about having to write a whole bunch of code and a new schema on top of that. Right? You might want to start with domain first. You will do that. And this will meet 80% of your requirements. But eventually you will come and tweak something. You'll drop a column, you'll define a schema to kind of take the place of this auto-generated schema. You will handwrite this one column schema and write a resolver to kind of support that. So for 80% of your needs, one of these approaches will work. For the other 20, you might want to lean on the other two. Right? So this is not a silver bullet. None of these approaches are. You will have to mix and match it, but only two of them let you kind of quickly deliver a GraphQL project and not kind of sit and write code endlessly. So that's one of the kind of patterns that has been emerging in the GraphQL ecosystem. The other thing that has happened is GraphQL is being used to solve increasingly complex problems. It was being used for a single graph earlier. Now it is being used for a graph of graphs, right? So you have multiple teams kind of collaborating without expensive coordination to contribute to a single supergraph, if you will, right? So the complexity of use cases is increasing because GraphQL has become this lingua franca for API platforms. So it's the problem with different teams, heterogeneous systems, different kinds of APIs. How do you kind of standardize that? You go back to that one takeaway I asked you to keep in mind, which is types that remain consistent regardless of what is there in your underlying domain. So this middle layer, if it speaks GraphQL, you kind of standardized whatever is happening in your individual domains to GraphQL, and therefore allow a consumer application to speak one language to any of your underlying domain sources. I use the word language loosely, please excuse that. I don't mean to imply C# or whatever. I just mean a particular way of interacting with your underlying domain. But no one needs to know whether underneath your API layers you have SQL Server, Postgres, Snowflake, or anything else that a front-end application should just never bother with. So that's what's happening with GraphQL. It is being used to solve the problem of building API platforms because it provides that language for people to standardize on. And the rest of this talk is kind of taking that approach and applying it to your underlying domains as well. So if you take a look at the GraphQL landscape, right, this is a pretty stock landscape diagram for the GraphQL ecosystem. You have tooling that helps you build kind of subgraphs on top of individual or multiple data sets or APIs managed by one team. You have tools that allow collaboration. There are tools that let you kind of consolidate this into that graph of graphs. And there are tools that help you kind of consume GraphQL APIs as well. And what we have seen in the recent past is that the subgraph tooling has been moving to more code first and domain driven approaches, right? And there's a whole host of things that have come up here, not just from independent vendors, but also from cloud providers. And the whole reason for this is if you go back to the origins of GraphQL, right? So this is a tweet from Nick Schrock, who's one of the co-developers of GraphQL back in Facebook. He's moved on to do other things. But he said that, hey, like a lot of people will fail to scale GraphQL or use it effectively because people forget that before GraphQL became a thing, Facebook had already kind of built out this data access layer, this common layer that interacted with I don't know, the newsfeed team, the contacts team, or the friends team, the market. And I don't think they had marketplace back then, but assume that the marketplace team had its own systems. Just standardizing all of them on a common scalable business object layer is something that Facebook had done before implementing a thin layer on top of that with GraphQL, right? Just to make the front end to multiple backends communication easier. Now, you can use it in completely different contexts if you want to. You're not required to use it only for those benefits. There's lots of benefits as you come down to the backend as well. And but having this kind of data access layer is something that is important. And one of the crux of the domain first approach is that you can be metadata driven to leverage your underlying databases as much as possible to be this business object layer. And I don't want to belabor this point, but if you think about it, you spend a lot of time getting your database domain right. That's the true snapshot of what is going on in your system, especially folks who work a lot with OLTP or relational databases, right? Database design is important because it captures the state of your systems. Everything else has to connect to this stateful system to understand what is going on. Domain first approaches posit that, hey, you've modeled your domain already. Why can't I also model your GraphQL schema using the same domain and take care of 80 to 90% of your needs? Most application code is CRUD. Most application code is just doing simple IO with the underlying database domain. Why don't we just allow that to happen as efficiently as possible? And if you need to customize, write business logic, which no one can help you with, right? That's the key principle of domain first approaches. And this is kind of where the GraphQL ecosystem is heading as well. In addition to all of those tools that I showed you in the ecosystem, which of course I'm biased with, you have all kinds of cloud provider services kind of taking the same approach. AWS has its own things. I won't get into that today. But Microsoft has, in the last 4 to 5 months, I guess, done two implementations of domain first APIs. One with Fabric that allows you to connect to a diverse set of data sources, and the other is a collaboration. Sorry for this shameless peddling here, but the point I'm trying to make is that if you have a Cosmos DB, you want GraphQL APIs on top of it, you can just use some middleware that will give you instant APIs and let you customize whatever you need for business logic, right? This is the direction in which I like to say non-profit or rather for-profit teams are headed. If you're a non-profit, if you're looking at like academic stuff and you have a lot of money to throw on professional services, you can start with, let's say, a schema first approach and so on. But the tea leaves have spoken, right? Like if you want to deliver successful GraphQL projects in this market, bootstrap your projects with more code first, more domain first stuff. Is my personal recommendation. So with that, we'll spend a couple of minutes on API platforms. I feel like I might be running late, so I'm going to rush through this. Again, not too many profound points that I want to make. Two simple points. Think of API platforms like marketplaces. There are API or data producers. There are API or data consumers. you want to make sure that both their concerns are addressed, and uh, this matchmaking of consumers and producers happens as efficiently as possible, right? That's the flywheel that you want to create of data consumption and supply, whether API format, gRPC versus REST versus GraphQL, none of that matters. Fundamentally, it's about data. People want to read it, people want to write to it, other people want to do the same as well. So just making this happen as seamlessly as possible is the role of API platforms. The second point I want to make is that API platforms, again, think of Amazon, if you will, right? As a user, you ideally don't want to write an email to a seller or a vendor on Amazon. You just want to see what kind of products you have available, check out the ratings, check out the metadata about it, and then be able to give your payment information and check it out yourself. Self-serve access to data is the goal of any API platform, which means that you need to do what is called, uh, not exclusively, but in the GraphQL ecosystem as federation. You should be able to provide on-demand federation across any of your subgraphs for you to provide an effective marketplace. So if, let's say, I provide, there are three teams or three sellers in our marketplace: users, orders, and reviews. These are managed by different teams. As a platform provider, as a platform architect or a developer, I should be able to let consumers of this API platform run queries such as this, right? Give me users who have placed more than 10 orders, sorted by the count of the reviews. So you can kind of imagine the GraphQL query or the SQL query if you want to, right? Select users, select start from users, where users dot order greater than 10, order by users dot reviews. Oversimplification, but users, orders, and reviews are managed by three different teams. Their interfaces are APIs. It's not three simple tables, right? It's three different teams and three different systems, three different APIs, if you will. And you need to be able to provide this kind of on-demand joins for a truly effective and powerful API platform. Because these are the use cases that you really need from an API platform, right? If your application is scoped just to the user's team, you probably have your own systems. You don't need like data from orders and reviews. It's a very simple process and something that you're used to. The moment you get into multi-team, multi-repo kind of situations is where things get tricky, because um, the choice of your boundary between teams, whether you choose to go straight to the data source, whether you choose to work with REST APIs, whether you choose to work with GraphQL APIs even, has a big bearing on how powerful your joins can be. There's some literature on this open framework called Supergraph. That we kind of we maintain that repo and encourage this discussion in the community. We've spoken at length about it, but the boundary at which you define the difference between team one and team two matters and has an impact on the quality of your API. But this is the goal of any powerful API platform. Least path of least resistance and effort to be able to do any kind of join. That's the API platform stuff. And as you kind of journey across GraphQL, your maturity is going to increase based on how many such teams are involved in your GraphQL platform. So I'm going to skip over this and just give me 1 second. I think I should be able to move to a demo. So give me 1 second. Let me just open up. Let me open the application that I had in mind for this demo. All right. Simon, could you give me a quick confirmation if you can hear me?
Yes, Sandeep, I can hear you loud and clear, but I think you stopped the screen share, or perhaps you closed the
I
browser.
did. I'm going to switch to a different browser.
Perfect. Yeah.
All right. Going again. Let me. Let me just share. If you can still hear me, I'm going to share this entire window so that
Mm-hmm.
it's easier.
Yeah, I see you.
Again, I'm going to use the tool. You can see my screen. All right, cool. So I'm going to use the tool that we built. I've created a special kind of project for the stream, and um, what I'm going to do is I have a couple of databases. I have two SQL Server databases. What I'm going to do in the next few minutes is build this API platform in front of you in the next few minutes using this domain first approach. All right. So this is my project. This is what is called Graphical in the GraphQL ecosystem. It's a tool that lets you play with your GraphQL API. I don't have any types, any data in my GraphQL API which is being served at this endpoint. Um, so you will not see anything here. So to remedy that, what I'm going to do is I am going to, I'm using a middleware tool that will derive your GraphQL schema from the underlying database, right? So it's a tool that supports a lot of things. I'm not going to get into any of that. I'm going to add a SQL Server database, right? Let me connect this. All right. So I'll give it a name. I'm going to call it subgraph1. I'm going to use a database URL. This is credentials. So these are open. So please do not hack my database uh, because the password is available here. So I'm just going to connect this. This is basically this middleware knowing the existence of my database. I'm doing something wrong here. SQL Server database, where is the password is database URL. Let me just do this. Oh, okay. This is erroring out. Thankfully, I do have another project where I did add this. So let me just quickly go here. Just a second. Just a second. How do I? Just a second. Huh. All right. So what I'm going to do is I'm going to have to reverse engineer this. So let me just remove some of the things that I had in another project. Apologies for this. I don't want to go to Azure and add uh, uh, this thing. Let me remove customers, modify, untrack table, continue. All right. I'm going to drop customer address as well, modify. Please bear with me, folks. A couple of minutes and I should be able to do this demo for you. Um, All right, cool. So I'm going to use this project instead. My apologies, I haven't whitelisted the IP of this new project in my Azure database. So I'm just going to use this new project called this thing mutual ostrich 64. It's a randomly generated thing. So assuming I was able to get through this step, right? What you would have seen is an interface that says that okay, this domain first tool has been able to talk to this SQL Server instance. It knows the existence of, let's say, two tables in this database, right? I did provide the database name in the connection string. So it knows that there is a table called customer. It also knows that there is a table called customer address. Now, customer and customer address are related to each other, right? So we will take a look at how to build, and this is in the same database for now. So we'll take a look at how to kind of define a relationship, expose these tables as part of our GraphQL schema and also build out a relationship. So let's do this step by step. So I'm going to track the customer table. Um, I also have a bunch of other tables already tracked. Please ignore them for the time being. I'm going to track the customer table. By tracking the customer table, I'm telling this domain first tool that, hey, The customer table, which is this, right, which has customer ID, name, title, first name, the usual uh, columns that you would expect in a customer table. I want to expose this data and this these columns and this data in my GraphQL API. So the moment I track it, the domain first tool introspects the schema of the table and is able to generate a GraphQL API that can support this. So for example, this is my table. We just looked at this one. I'm going to query first name, last name, and customer ID, and I'm going to simply run this query. It's going to take a few seconds. I can speed this up by adding caching as well. Um, but I'm instantly able to go from pointing this tool to my database and getting a GraphQL API that is able to query this. Now, just to show you that I'm not doing any hand waving here, I'm just going to go and change. Can I edit this? Yeah, we don't support this for SQL Server, but I can maybe see if I can insert. Uh, Not really, but this is my data set, and this is the same data set that I'm able to query. A customer ID one is G Orlando. Let's go back to our data and run this again. And in a few seconds, we will have the same data. I really wanted to edit this and show you that this is not made up. Now I can sense the skeptics in the audience are like, hey, my model code will give me this. This is just API on top of a single table. What the hell are you trying to prove here? You're right. It doesn't make a lot of sense to do this on just one table because that's what your ORM, any ORM or model layer will give you. I also want to track customer address, right? Um, Let me track customer address now. Now, let's take a look at the schema of this thing. Very naturally, it has a customer ID and an address ID and address type and so on. It is not very hard to imagine that if I can query the customer table, I can also query the customer address table, which we just tracked, right? So let me get this and let me run this query instead of the customer this thing. Um, so now I have this, I have data coming from this table as well, right? Again, the same thing, I have auto-generated this API, this GraphQL API on a single table. The interesting thing is that if I want to take, let's say, this customer ID and join it on the customer table and get customer data and address data in the same query, I would have had to write some code, um, uh, some controller code, some model code to kind of join this, to define that relationship and filter them based on this join condition. Or I would have had to write a custom SQL and then expose that as code. Um, I don't need to do anything of that sort because I am taking advantage of the domain. If I go back to my data tab, I know that there is a foreign key constraint from customer address, customer ID to customer ID. I'm going to track this. The moment I do this, and if I go to my customer address table, I can define a relationship because we know foreign key constraints can let you have one-to-one or one-to-many relationships between two sets of tables. For example, customer can have multiple addresses. So if I go to the customer table, I'm going to go to the relationships tab, and it can already suggest this, right? Um, Sorry, did this already exist? Like this definition already existed. Customer.customer ID is equal to customer address.customer ID. It's a relationship I can define because I track the foreign key constraint and I ask the GraphQL schema to also learn from that foreign key constraint. So it automatically adds this relationship. The inverse is also true. By the way, this is an array relationship because customer can have multiple addresses. You will see the others in the relationship definition here. Uh, I can add a customer relationship from customer address to this. Now, this is going to be an object relationship, a one-to-one relationship. So let me just quickly add this. I'm going to call this customer. Let me track this relationship. Okay, by virtue of doing that, what now happens is where I was simply querying a simple table, I can now say, get me data from a related table. So if you see this customer address field in my schema, it suddenly has this new thing called customer here. That's because we added that relationship. I can choose to start querying first name, last name here. So for every address, I can get the corresponding customer in the same request. I can run this query. This is a
Sandeep,
JSON.
Sandeep,
Yeah.
I'm sorry to interrupt. Perhaps it's time to wrap. Yeah.
All right, cool. So
Yeah.
I think I'm almost through with this. I was able to show you how to kind of compose or do this on-demand join on two tables. You can extrapolate this across two databases as well. And what I mean by domain first or being metadata driven is just this. Just give me 1 second. Let me just open. Uh, right? Everything that we looked at, everything that we did in that pretty UI is actually adding to a JSON or YAML specification. And this is what it means to be domain first or metadata driven. You take the underlying domain, you translate it into something standardized, what we call metadata. And what you did for SQL Server, you can do it on Snowflake, you can do it on Postgres, standardize all of them on this JSON that you're looking at, and have a way for you to query any underlying source with this information. So